Okay, it's time now to take a quiz over what you've learned. So question number 1, an object has a mass of 10 grams. Its volume is 5 cubic centimeters. What is its density in grams per cubic centimeter? So we're going to use the formula for density. So density is mass divided by volume. So we're going to say rho equals mass divided by volume. So the mass is going to be 10 grams, and then the volume is going to be 5 cubic centimeters. So therefore 10 divided by 5 is going to be 2, but let's put in our units. So it's going to be grams per centimeter cubed. Okay, question number 2. Two objects have the same mass, but they have different volumes. Which object would have the higher density? So we're going to compare the density of two different objects. Now the M is not going to change, but the V is. So if you want to have a large rho, a large density, what should you do to the V? Should you make it bigger or smaller? So if you make the bottom part of a fraction bigger, what comes out gets smaller. That's not what we want. We want it to get bigger, so that means we want the volume to be smaller. So the one that has the smaller volume is going to have the higher density. Question number 3, what is a stress? So a stress is going to be when you apply a force to an area. Okay, then what is a strain? So a strain is going to tell you how does the material change when you apply the stress to it. So it's going to be the change in some kind of dimension, could be the length, could be the area, but it's something having to do with the change in some dimension divided by whatever the original dimension was of the object. Number 5, what does the size of the spring constant tell you about the spring? Okay, so here is our formula for a spring. The force on a spring is going to be equal to the spring constant, and then how far does the spring stretch? So the change in the length of the spring. So what is the significance of the spring constant? So if this is a big number, then this is a small number. If this is a small number, this will end up being a big number. So the spring constant is going to be the stiffness of the spring. The stiffer the spring, the larger its spring constant is going to be. Number 6, use the spring force equation to predict what would happen to the force on a spring if the stretch was doubled. So if we multiply one side of the equation by 2, so that we have 2 times the stretch, then we got to multiply the other side of the equation by 2. So that if you double the stretch, you're going to double the amount of force that it's going to be applying. And then number 7, how do real materials behave as the stress on them increases? So at first, they're going to behave elastically, which means that if you double the stress, then you double the strain. And so this is when it's behaving elastically. But eventually, it's going to come to the point at which it's going to start behaving like a plastic, and then it starts to do that. And when you release the stress, then it no longer returns back to its original shape. And then if you continue to apply stress, it's going to break. And so we say that it's going to rupture when that happens. And so that's that part of the graph. Okay, so there was a discussion of how solids behave. So in our next lecture, we're going to talk about how do liquids behave. So I will see you then.